In this video, I'm going to lay out as simply as possible how to manage quality on a project. There's going to be no confusing terms, no confusing theories, just step by step what you need to do to manage quality on a project. These are the exact steps I go through on every single project I work on in my 10-year career across civil infrastructure, renewable energy, and oil and gas projects. These steps work to make sure that we're checking and inspecting what we're building, we're avoiding defects, and we're ultimately building what we said we were going to build. We'll go through each step in the process and its role. Let's start off by focusing on what the ultimate objective of quality management is. The ultimate objective of project quality management is to ensure that what we're building meets the original project requirements. So any project is undertaken to fulfill some need or objective. We're building an apartment complex, it's there to provide housing. If we're building a solar farm, it's there to produce electricity. These original requirements get transferred into a set of drawings and specifications. These drawings get built, and then there needs to be some process in place to ensure that what's built matches these original requirements. So that's the goal of project quality management. So the first part of this process is to ensure that the drawings and specifications capture these requirements. So these requirements get turned into, through the design process, get turned into a set of drawings and specifications. So the first part, the quality management process, is ensuring that these drawings capture all of the original requirements. The second part of this process is through construction, when these drawings get turned into a finished product, ensuring that what gets built matches the drawing. So this is more construction quality assurance, and it's about ensuring what we build matches the drawings. Now we understand very simply what the quality management process is doing and the two core functions of it through the design, through construction. Let's look at how this maps across to the project lifecycle. Okay, so looking at the lifecycle of a typical construction project starts off with the concept design. So the initial requirements are transferred into a high-level set of drawings and specifications that broadly outline what we're going to be building. Once they're happy with the concept design, it moves into detailed design. So this is where we go from 15% design to an issue for construction drawing set, detailed drawings and specifications that show exactly what we need to build. Concept design might provide a general layout of the building. The detailed design is going to tell you exactly how thick every wall is, what material every wall is going to be made from, the heights of the slab, absolutely everything. Once we get the issue for construction drawing set, we'll start the pre-construction process. So this is planning the work, and specifically with quality, setting up the systems and processes we're going to be following, writing all our inspection and test plans, these sorts of things. We move into construction, where we deliver the works and we need to complete our quality control activities. So inspection and testing and checking everything's been built correctly. Once the works are finished, once we've checked everything, once we've closed out all our defects, we can then hand over the finished project. Okay, so step number one, we need to plan our systems and processes. So this is about developing a plan of how we're going to achieve the quality objectives. And there's two key questions we need to answer with our plan. What processes are we going to follow, and what systems are we going to use? We capture this in a document called the Quality Management Plan, where we outline the project lifecycle and identify the processes we're going to be following. So what actions are we going to take at each stage of the project lifecycle to ensure quality? So we'll talk about, if we're buying equipment, we might document what factory acceptance testing we're going to do. During construction, we'll document what activities we do inspection and testing. We also need to identify the systems we're going to be using. So we're going to use a quality management software, or we're going to use paper-based forms and track it on Microsoft Excel. So that's the system we're using. Step number two is we need to capture stakeholder requirements. So we need to identify and correctly capture all of the requirements from our stakeholders and integrate these into the concept design. So this will be going to all the potential people who are impacted by the project, who are invested in our project, and understand what their needs and objectives for the project are, and integrate these into our concept design, which is more broadly part of project scope management. As an example, if we're building a solar farm, our stakeholders could be the operations and maintenance team, the utility provider, the client, and the community. So the operations and maintenance team might want easy access for regular maintenance to specific bits of equipment. The utility provider will want grid compliance, power stability. Our client is all about maximizing their return on investment and achieving the project timelines. And the community are concerned with noise and the environmental impact. So these are the requirements from all these different stakeholders that will need to integrate into the concept design. Step number 3 is after we've completed the design, we need to then check that the design we've created meets the stakeholder requirements. So we'll develop a detailed design and then we'll check the design meets all of these requirements. We can do this by design reviews, giving the stakeholders access to the drawings so they can perform their own checks, and doing a detailed cross-check against all of the project specifications and ensure all of the requirements are captured in the drawings. For example, if we take the operations and maintenance requirements for our solar farm, what we could do is check against all the equipment they need access to and make sure that there's safe maintenance access. We can make sure there's walkways around the inverters, whether they've got access to cut the grass between the panels. We can also provide them the drawings so they can do their own checks and comments. And then we can look at the specific list of requirements and tick off every single one of these requirements that they've been integrated into the design. Then after the design's developed, we move into the pre-construction process, which is step 4. So our detailed design captures the necessary information to go out and build the project. Pre-construction is where we do the planning and preparation before we begin construction. So this will consist of procurement, where we select high quality subcontractors that we know can deliver the works correctly. And we also prepare all of our inspection and test plans. Biggest part of this in terms of quality management will be writing all our inspection and test plans. To do this, we first need to have a work breakdown structure. So we take the project scope, we break it down into component pieces such as civil, mechanical, and electrical. And against every single activity, we determine what inspection and testing and checks we're going to do to make sure the works are done correctly. For each of these different activities, our ITP is a step-by-step checklist that we use to check at every stage of the works what we're delivering matches the original requirements. This document is a critically important document. We'll send it to our client, our stakeholders to review and check to also make sure they're happy with the checks that we're doing. After the pre-construction phase, we move into construction. So during the construction phase, all we need to do, because we've already set up our inspection and test plans, is simply follow them by the letter of the law throughout the process. So for example, with civil works, if we've got an ITP that says we check the correct material is used and the evidence is the dockets, that's what we'll do. We'll complete compaction testing. We'll complete a proof roll. So whatever that ITP says we're going to do during construction, that's what we do. Any failures to meet the requirements set out in our ITPs will result in a defect. So for example, we fail a proof roll during civil works, that is a defect that needs to be rectified. So these defects all get recorded on a punch list. The punch list needs to be closed out progressively as the works are done so we can prove that any defects that have come up during construction, we've closed out. Another important thing to keep track of during construction is managing change. So our quality requirements will be based on the issue for construction drawing set. So the set of drawings we've agreed to build. However, during construction, designs change because designs can be wrong. They might not be applicable. They might be changed for other unforeseen reasons, or they might be changed at stakeholder requests. So any changes to the drawings need to be checked and approved by the design team through the RFI or request for information process. For example, say we're building a car park and we're installing new light pole foundations and the foundation for the light pole clashes with an existing underground service. What we need to do is then we need to get this checked by the design team and get direction from them for what we're meant to do about this clash. We might have to move the light pole 500 mil to a different direction. That way the design team can put in all their checks to make sure that the foundation is not going to now clash with the curb, that we're still going to maintain the required lux levels or lighting levels in the car park, and basically check that as we change the design, we're still achieving the project requirements. So through the RFI process, we continually make sure that if there's any changes to the design, we're still maintaining and achieving our project requirements. Once we've finished all of the construction works, we're going to hand it over and close out the project. We can only do this once we've completed all our quality control activities. We've completed all of our inspection and testing, checked everything is correct, complies with the specifications, close off our punch list. We can show that we've closed all our defects, and then we'll also do some handover walks with our clients and joint inspections, which gives them an opportunity to raise and identify any defects, so we can also close these out. Once we've completed all our quality control activities, once we've checked everything is correct, we've fixed any defects, we can then successfully hand over the project. Okay, in summary, quality management is just a series of steps we do at different stages of the project. It's as simple as that. Following these steps is going to ultimately ensure that what we've built through the design process, through the construction process, is ultimately correct and meets the original requirements for the project.